Hey there, this is Kateshi, yeah, and I'm going to be taking you for core mathematics here. Okay, so in this series of my lesson TV, core mathematics, I'll tackle the high yield topics, okay, the topics that usually surface in the exams, WASI or any, yeah, so I would like to start with logarithms, okay, this is basic, and okay, without wasting much time, let's focus on. So I'll give an intro to the topic, and then we talk about the rules of logarithms. That's the short form logs, okay. And then we're going to talk about properties of logarithms. Then we talk about change of base. And logarithmic equations. That's equations that involve logs, okay. Logarithmic equations. And then if we have time, we talk about characteristics. We talk about characteristics and mantissa. Well, these names will maybe don't let these names actually threaten you or something, frighten you, but you get used to once we are able to go through all. Okay, so we have log tables here. Those logarithm tables. I'll try and see if I can help you understand and be able to interpret and use the logarithmic tables. And also talk about antilogs. Okay, so let's start with the introduction. Okay, so basically when we talk about logarithms, it's not anything difficult. Okay, we are familiar with these exponential equations. Okay, that's, for example, if I write 100, it is the same as 10 exponent 2, okay, or 10 raised to the power 2, okay, and these have names. Okay, we call the 10 this number the base, and then the 2 here the index or exponent or power. Okay, so we can express this in the logarithmic form. Okay, for example, if I say make 10 the subject, it's easy. You just find the square root, okay, or the half. You just a square root, okay. So you find the square root of both sides, and you can make 10 the subject. As in this case, if I find the square root of both sides, this square root sign cancels the 2, okay, or in other words, 100 exponent half square root is same as the half root, or let me say the second root. So 10 exponent 2 exponent half, okay, so this cancels that, and then now we have 100 here. So that means I'm making 10 the subject. Okay, so 10 is equal to square root of 100, so that's it, or square root of 100 is equal to 2. But what if I say make the index the subject, make 2 the subject? That is where the problem comes in, and so there is the need to introduce what? Logarithms. Okay, so that's why we need logarithms. Okay, so in this case where we have 100, in this case where we have 100 is equal to 10 exponent 2, we can make 2 the subject by finding the logarithm of both sides. Okay, so we can say that log, this is the base, log and of this number, log of 100 to the base 10 is equal to 2. Okay, so now we've introduced the log, so this is where logs come in. And so generally when we are being given an expression, an exponential equation, b is equal to a exponent n. Okay, we need to, in this case, n is the index and then a is the base. A is the base. Okay, so we find the log of b to the base a, okay, or both sides. So this is how we do it. log of b base a will be equal to the index n. Okay, so generally when I'm being given an equation that says that b in the form of b is equal to a exponent n, just write it in this form. Log a, the other form is log b to the base a is equal to n. Okay, so we can play with some numbers. Okay, for example, given that 3 exponent 5 is equal to 243, okay, and you're asked to write it in the logarithmic form, it's just you have to know what is the index and what is the number we are talking about and what is the base. So this number here, 5, is our index, and then 3 is the base, and then this is the number, okay. So in the logarithmic form, it's going to be log of 243 to the base 3 is equal to 5. Okay, or in other words, it's the same as saying that we can read this as 5 is the logarithm of 243 to the base 3. Okay, so that's the meaning of this expression. So that's the introduction. Okay, so you can play around with these numbers. For example, we know that 3 exponent 4 is 81, right? So what would be the logarithmic form? Log of 81 to the base 3 is equal to 4. Or you can read it as 4 is the logarithm of 81 to the base 3. Yeah. Let's take another example. Let's play around. Okay, so we have 3 exponent minus 3. Don't be frightened by this negative sign. So in other words, this is the same as what? 3 exponent negative 3 is just 1 over 3 exponent 3, which is also 1 over 27. So ideally, 3 exponent negative 3 is equal to 1 over 27. So we're writing this in the logarithmic form. What do you think it will be? So now you need to first identify your index. So this is our index, this is our base, this is our base, and this is our number. So what do you think it will be? It's of this form it's of the form a exponent n is equal to b. So we are saying the log of which number? Of 1 out of 27 to which base? Yeah, I'm waiting for you. Okay, now the base is 3, not negative 3. So the base 3 is what? Negative 3. So in other words, negative 3 is the logarithm of 1 out of 27 to the base 3. Yeah, that's it. So you can try your hands on 6 is negative 2 is equal to 1 out of 36. You can try your hands on these, okay, on this, and then 6 exponent 2 is equal to 36. Just try your hands. Let's try your hands on that. Okay, so we are moving to next stop is the rules of logarithm. The rules of logarithm. So I'm just going to state the rules, and then in my next video, the next video after this, I'll try to prove to you the rules, how we deduced these rules. Okay. So the first rule is the addition of logarithms, or we can say that log of, let's say, a number multiplication, log of m times n to the base, say, a, is equal to log of m to the base a plus log of n to the base a. Remember, they must be of the same basis. Okay, so when I add 2 logs of the same basis, like multiplying these 2 numbers, okay, that's what we have here. And then the second is the second rule will be the division. Okay, so log of m out of n to the base a is equal to log of m to the base a minus log of n to the base a. Remember, they must be of the same basis, okay, before you can either express them in this form, okay, or convert from this form to the other. Okay, so the third rule is simple, is log of a to the base, log of n exponent b to the base a is equal to b times log of n to the base a. Remember, this is not block, but rather b. Okay, b. So let me highlight that. So b log n to the base a. Okay, thank you very much for your attention.